Polynomial functions are classified by their degree. The graphs of polynomial functions are classified by the degree of the polynomial. Each graph based on the degree has a distinctive shape and characteristics. We know that a first degree polynomial is a linear function. We know a second degree polynomial is a quadratic function. We know that a third degree polynomial is a cubic function. A fourth degree polynomial is a quartic. It is a fourth degree polynomial. And a quintic is a fifth degree polynomial. And I believe one of the questions on the assessment this week does ask you to name the polynomial. So make sure that you know how to name a polynomial using the degree. Then the end behavior of a function, and usually when we ask for end behavior, we'll just say as x approaches positive infinity, what does the y value do? As x approaches negative infinity, what does the y value do? And a lot of times, you know, when we do this, all we'll do is we'll just say, as x approaches positive infinity, y approaches, and whatever it approaches. I mean, it might approach positive infinity also. Or you could say as x approaches negative infinity, then y approaches maybe positive infinity also. We don't know, okay? But we can tell what a function does. We can tell what the end behavior does by just looking at the leading coefficient and the degree of the polynomial. There's only 4 different ways a polynomial can end up, and those 4 are right here. If the leading coefficient is going to be positive, okay, because the leading coefficient can be either positive or negative. If the leading coefficient is positive and the degree is odd, then the end behavior will always look like this. The end behavior on the right-hand side is going to go up. The end behavior on the left-hand side is going to go down. Now, I could give you a function. I could say, okay, y is equal to 3x to the 5th plus 4x squared minus 3x plus 5. I don't know what this function looks like, but I do know that the end behavior will look exactly like this. I mean, the function might look like this, but I know the end behavior is going to go up on the right-hand side and down on the left-hand side. Why do I know that? The leading coefficient is odd, and the power, the leading coefficient is positive, and the power is odd. That's what makes the end behavior. If the end behavior is going to go, if we have y is equal to negative 1x, that is a linear function, and it looks like this. All functions that have a leading coefficient of negative and an odd power, the end behavior will always look like this. So for example, if I had y is equal to negative 3x to the 7th plus 5x squared, I don't know what the rest of this graph looks like, but I do know that, I mean, it might look like this. I do know what the end behaviors are going to do. On the very left-hand side, it's going to go up, and on the very right-hand side, it's going to go down. That is what the leading coefficient and the degree tell us. If we had y is equal to 1x squared, the leading coefficient is positive, the degree is even. If that ever happens, we know that the end behavior will go up on both sides. If the leading coefficient is negative and the power is even, it's going to go down on both sides, and it doesn't matter. So for example, if I had negative 7x to the 8th plus 5x squared plus 3, I don't know what this graph looks like, but I do know, I mean, it might look like something like this, but I do know that on the ends, it's going to go down. Why do I know that? The leading coefficient is negative, the degree is even. So whenever you're looking at a function and you want to know what the end behavior is, all you have to do is look at the leading coefficient and the power. It tells you exactly what's going to happen. All right, and here is the way our book shows it, which is exactly the same as the slide I had. Identify whether the function's graph has an odd or even degree and a positive or negative leading coefficient. Well, this one, if I look at it, it looks very similar to this graph, right? It's going up on both sides. What did this graph look like? It looked like 1x squared. Leading coefficient is positive. power is even. So I know that this has this function right here has an even power and a leading coefficient that is positive. I don't know what the leading coefficient is, and I don't know what the power is. I just know that it's going to be even, and I know it's going to be positive. Identify whether the function's graph has an odd or even degree, positive or negative leading coefficient. Well, this one looks very similar to the graph that I have that looks like this, right? That's what the leading, so that was negative 1x to the first. So I know that this graph, the leading coefficient is negative, and the power is going to be odd because it's the end behavior looks like this one. Identify whether the function's graph is odd or even. Now this one is very similar to the last one that we did. It's going up on both sides, so I know it's going to be leading coefficient is going to be positive, and the degree is going to be even. So if they give me a function, I mean, it doesn't have to be graphed. Identify the leading coefficient, degree, and end behavior. Okay, so in this problem, make sure you always write it in standard form, because standard form, if it's not in standard form, then the leading coefficient is not right. So in this problem, the leading coefficient is going to be -1, and the power is even. So I know that the end behavior is going to look like this. So as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y is going to go to negative infinity. They're both going down. So my end behavior is going to go down on both sides. And this is what the graph looks like. Now, today, we're going to take this a step farther. You should be able to write an equation by the end of today. You should be able to write an equation of this function. And you should be able to, right away, I know that there's a couple things that when I look at this, if I was going to write an equation for this, first thing that I do is I look at what the zeros are. Okay, so it looks like it crosses at -3, -1, and 2. Now, it's really weird at -1, and it's really weird at 2, okay? But -3, not bad at all. So I know that this is going to factor to x plus 3. I do know that this is going to have a even degree, and it's going to have a positive leading coefficient. I don't know what the leading coefficient is, but I'm just going to put +1 in there. Okay, now at -1, so that means at x plus 1, something's happening. If you ever find a graph that comes up, touches, and then continues up and makes an S shape, this has, if it just crosses once, the degree is 1. But if it just touches and then goes up and makes like an S shape here, this has a degree of either 3, 5, 7, 9. It's going to be an odd degree, but it's going to be either 3, 5, 7, 9. The flatter it gets, the higher the degree is. So this one, I'm just going to use a 3 here. So this is going to be x plus 1 to the third power. And then here, this is I know that that's a solution, so x minus 2. But if it touches and goes back up, I know that this is going to be an even degree. It's going to be either 2, 4, 6, 8, I don't know. But the fatter it is down here, then the higher the degree is. Kind of looks like it's just touches and goes back up. So I'm just going to use a second degree. So what degree is my polynomial now? This is the first degree, third degree, second degree. So that's 5, 6. I knew that my polynomial had to be a 6th degree polynomial, right? Because it has to be even and positive. So that is how I write a polynomial function for a graph. Okay, so it's really kind of cool. You really have to understand what those are, and we're going to go through that right now. Oops, kind of went through that real fast. Okay, so this kind of talks through how they came up, but the multiplicity, that means how many solutions there are. This is a my marker's not on. This is a multiplicity of just 1 because it goes straight through. So I know that it's just 1. Here, since it's an S shape, it's going to be an odd degree, so it's either going to be 3, 5, 7. Usually we just use the lower one. And if it touches and goes up, it's going to be an even multiplicity. So it could be 2, 4, 6, 8, whatever. Usually we just use the lower one. And if it came down and it was really flat and then went back up, it stayed down there a long time, then it would have a higher one. Same thing here. So that's called multiplicity. So when I'm looking at a graph, if it just crosses, just 1. If it touches and goes back up, we say it has multiplicity of 2. If it is an S shape, we say it's multiplicity of 3. So if they ask me to write an equation of this, okay, it says use the graph of the function of degree 6 to identify the zeros of the function and their possible multiplicities. Well, I'd also want you to be able to write an equation for this. Okay, so in order to write an equation for this, first thing I do is I figure out where it crosses. -3, -1, and 4. I know that the leading coefficient is positive, so I'm just going to put +1 there. Okay, and then this is going to be x plus 3. And it hits and goes back up, so I'm going to say that's the second power. Here I have x minus 1, goes right through, so I'm just going to put x plus 1 there. Here, this is like an S shape here, so this is going to be x minus 4 to the third power. Now, I know that this has to be an even degree, so here I have 2 degrees here, 1 degree here, so that's 3 plus 3, that's 6. This is a 6-degree polynomial. Pretty cool, being able to write an equation of a polynomial function just by looking at its graph and knowing what the multiplicities are for that. Okay, and if we're going to sketch a graph, so if I asked you to sketch something like this, let me change this a little bit to make it a little bit tougher on us. Let's say that this is to the second power and this is to the third power. And I asked you to sketch a graph of that. Okay, well, if I was going to sketch a graph here, I just figure out what my zeros are. So 0 is a solution, and 5x, that's -2/5 to the second power, and x minus 4, so that's 4. So I know at 0, it's going to cross. Let me change. So at 0, it's going to cross just one time. And this is, what is this? This is a 6-degree polynomial. So 3, 4, 5, 6. And it has a leading coefficient of 1, so that's positive. So I know my end behavior is going to look like this, right? 6 degree, positive leading coefficient. All right, so 0, -2/5, that's like over here someplace, and positive 4. I know that it's going to, my end value is going to come here, and I know it's going to go up here. So I just draw those in. So then it might look something like this. Comes up. Let's see here. So this is at 0, it just, ooh, wrong, because this is, so this is going to, so this is going to have to come up like this because it, remember, it has a second degree there. So that means it comes up, hits, goes down here. So then it might, and this is just goes through, and then this one comes up and makes like an S shape. kind of, let's get rid of that line right there. But that's what my graph is going to look like, something very similar to that. So you've got to look at end behavior. What's the end of the graph going to do? You have to look at where it crosses the x-axis and what's happening when it crosses the x-axis. Is it hitting and going back up? Is it making an S shape there? So those are things you have to